Hello and welcome to another video. It's been a while. Um, I thought I would look at something quite old. So this is old. You call it a terminal, a computer terminal. So this would they would connect to like another like mainframe that took up side of a room or something. So the funny thing is, this is actually like this terminal here is based on this, which I don't know. I find it kind of funny that something from like 1980s is like still kind of the de facto standard. Didn't want to click there. Um, so that's kind of interesting. This page doesn't really say too much, but there's this other site, VT100.net, which has quite a lot of information about like lots of different, um, all the different versions and whatnot. And they also have a like state machine for it. So this thing here, if we make that big, this state machine, which can like almost fit on a screen, the other way here. This isn't making the image any bigger. The text is tiny, but the image is just stayed the same. So I guess we'll go back to that, and perhaps we can open this. How is this defined? This is text. How come browsers these days? I should write mine or something. So this is text, but for some reason, like if you scroll to almost invisible, this text that I can select and whatnot. I mean, I guess it's like a SVG or something. Yeah, so it's like in an SVG. I would have thought that that would like scale, but does not. Anyhow, I mean, it's almost can fit on my screen. I could get a bigger screen that might fit on it. I could probably push like F11 and it would go, it'll lose the title bar and whatnot. So, anyhow, I'm just rambling about modern technology and whatnot. So this is basically something that will do like basically all the VTs up to 500. And they say 500 series because there's a few of them. I think they say something about that. 500 is shorthand for the series 510, 520, and 525. So, this is kind of cool because this is like quite a small state machine, I guess. So, for people that don't really know how to read state machines, this one is maybe a little different because it's got this like gray anywhere thing, which means any time, like in whichever state you're in, and we'll get to how you get to states. If you have one of these keys, you'll do this action or that action or no action in that case, and then you'll follow the arrow into whichever new state it is. So how you start this whole thing, pardon me, I'm going to have some water because I forgot that talking lots makes you thirsty. So, how do you start this whole thing? You find like a dot or something, or it might call it like origin or something like that. Basically, you go from here and you follow the arrow. Easy. When you're in this state, so this is basically like if you know Vim, it's like normal mode. If you don't know Vim, it's basically like where you normally are. Like if you're just typing a normal letter, it will be in this mode. So, there's a few keys that will like get you in here. Note that if it's got like 8 or higher in the first column, it's like definitely not a character you can type, but it's like outside of the first like 100. What am I getting at? First 128 bytes in the ASCII. Or maybe if I bring up ASCII table .com, yeah, that's like a thing that just shows you what it all is. You scroll up in this in images, so like this is an image, which SVG is also kind of an image. Interesting. The ads kind of also scroll up, which is kind of annoying, but that's just what it is. So, this is like it came from somewhere else. So this is basically all the characters or keys that your computer might send, or like the terminal might receive or send, going back and forth. Look at all these ads just like slowly coming up. The internet must be slow in this room at the moment. Sometimes the Wi-Fi is a little funny. Ads, man. Like back in like the 2000s, you had all those like flash pop-ups and whatnot, and we moved on. I don't know where we've moved to, but there's no cookies on the site, or like if there are, they're doing it illegally because they didn't ask me about the cookies. Anyhow, I'm getting off top. I might find another one. ASCII table. Just like a nice, easy looking thing, like a PDF. Won't have an ad, surely. I like how DuckDuckGo gets it from that, but I would kind of like it in a nice kind of thing. I used to have a man page that did it, but something overwrote that man page with a different thing. This is also not what I want. I wonder if I can find that man page just by doing that. And is this the one I want? We can do it. Yeah, so they have like a smaller kind of version for the printable characters, but you can kind of see here, this is like 2 columns. Here you have like a bunch of things that like you can't really do, but like they might do something. So like might make a noise or a flash. Backspace might do something to a cursor, and like all these things. And so like it's got a few things. Interesting. And then down here it has a space to start us off, and then the rest is printable characters up until right at the end you have Dell. And you see here it goes to 7F. It kind of means that there is more. And the ASCII-table.com did have the extended, what you call the extended ASCII table. But yeah, what I'm trying to say is basically if it starts with 80 or above, it's treated differently. And they make a note that somewhere, like when they talk it like that, basically they're kind of matched to what it was. So like if it's higher, like here it's saying from AO to FF, it's the same as 2O to FF. And that's like from the one of the many standards. So there's a few standards that talk about this stuff, which we might talk about, we might not. But then, like, the low ones also kind of do this as well. So, but also kind of not. Because, so like here you see like 0 to 17, which is basically the same as 0 to 97. So it skips 90 there. It will do an execute. So the same thing there, but it'll end up in ground. But there was just a comment about that. And 9, the same. And all of these 2-digit numbers are in hexadecimal. So you just need to learn how to read hexadecimal. But we'll talk about that when we get to the code. So when we're in ground, when we receive one of these keys, we do execute, which is an action. We'll talk about that in a sec. If we get one of 20 to 7F, which were the printable characters that we could see in this table here. So basically, space, all of these are just normal characters, and you can see them here, down here as well. And just ignore the del and ignore the del, because this thing also ignores the del by only going to 7F. And so that's what this does. Now, to save a bunch of errors, they have the anywhere thing, which I mentioned briefly before. So what, instead of having the anywhere, it might have had errors from each of the states into each of the states. So it might be a bit confusing, like, oh, you're in ground and like all these errors are coming in, but like, where is it going after that? So all of these keys don't actually mention everything from 00 to all the way to FF. There's a bunch more keys that could be done. So one example is 1B, the escape key. And so this is what kicks off like the ANSI escape code type things, which I've also mentioned in the past. And like you see, there's that picture. It turns up. So it's what makes like colors and whatnot show up a bit more. So this page also talks a bit about just escape sequences in general, and there's a few different types. So like when you hit an escape key, you open up this world of all these different functions that you can call on your terminal, which looks quite bland, but some terminals can do color, and some terminals can do even more color. So that's like quite a few colors. And you can do like a bunch of things. So that's kind of cool. And we might talk about some of those. But for now, say we're going to this escape mode. And you see here, on the entry, we do a thing. So we do an action, which is this clear action. And then we've got a few keys, and then we do execute. And so it's the same execute seen in a few places. And we've also got this other ignore, and there's ignore also caught from a few places in here. And this one has arrows coming from it to make it a bit easier to see what's happening. So if you have keys like this, you do this event, I think they call it, action, and then you go into this state. So this is how you get from this point here, the entry, into ground, and then you hit an escape key, now you're in this state, and then you hit a space or something, which is 20, and then now you're in this state. And this does some things, and one of which is collect. Now collect needs to remember the keys that are done. Because when it reaches one of these keys, it calls this event escape dispatch, and that dispatch needs to remember all of the keys that were collected beforehand. And sometimes there are none, so it might go from this and straight into the escape dispatch, and that's like if one of a certain particular key matches. And that's talked about a bit more in this wiki page, like which keys kind of kick things off. So you have like escape, then you have this bracket, but like before the bracket you can have things, and then you end it with one of these. You can have these like in the middle somewhere, and you can also have this like at this to separate all your parameters. And all of that is kind of described by this like escape branch from various things. So you see, escape actually points to a lot of things. And CSI, which is the control screen interface or something, that's probably what it stands for. Might not be, but it controls the screen interface, so maybe. And this does some other things. And this 5B will be a open square bracket. This diagram, like, I don't know, big ups to Paul. It would be really cool if it showed like the characters just for quick familiarity or something, but I understand that space is a bit of a concern sometimes, and like for ranges you can't put that, and yeah. But anyhow, that will be the open square bracket. Get into here, and then it's got all the different branches, and it's got like an error state, so you can have ignore, and then eventually you get back to ground, and or you follow one of these paths into the dispatch, which will be a key or an event, or it will change the monitor in some way, or set a color, or all kinds of things. And then here you have OSC string, which is slightly different because it will kind of do OSC put, which kind of sends it just directly to the whatever function that is defined by I can't remember why. I think it's just sent all up, so it's basically stored, but yeah, I don't know. It's done differently here because you can have other, yeah, so like in this collect it's different from this RAM, and this, well, I mean this collector is kind of the same, but yeah, I don't know why this wasn't collect. He does talk a bit about that, but I think it was mainly for this DCS thing, but anyhow, what I'm planning on doing is, yeah, so here for codes, that to that, and the symmetry does not extend to the bottom codes like there, so that's why you kind of had to spell out those, but over 9C, everything else is wrapped around. So, what I'm planning on doing is implementing that. And I think I had a thing called VT. Yeah, I did, and it's got nothing in it. So what shall we do? What I might do is make a VT.c maybe, and we can remember how to type on this keyboard, and do that, and maybe we can have a main function, and maybe I'll declare those, but I think there's like a attribute you can do. I might look it up briefly, but I think you can do something like attribute, and then like unused, something like that. I'll see if it complains at me. But anyhow, we'll do printf and maybe like a hello world. and learn how to we get everything in the right place, and maybe we'll return at 0 at the end. So what I might do is I'll set a make erg. In fact, this may have a thing like that, and we can probably take away these and run that. And then now I can kind of run this. And so now it doesn't know that. So I might just look up that and see because in the past I've no, I don't want to do that. This is the thing that I want. Like a double bracket, so I guess I can go YS, do that, and do that. I didn't really want to do that. We can change that to that, and do that. Yeah, cool. So now it complains about one, but not the others. So now we like yank to the space, and then find that C, and then uh, I love when you come up with like something really, yeah, that'll be really efficient, but then you push keys and then like you lose your cursor in the line. I wonder if there's a way to like go back to the position in the line that you are on. Hard to know. Anyhow, so now this should kind of work. And what I want to do, so I kind of want to do a few different things before I kind of start this, just to make it a bit easier to start things off, I guess. Because what I don't know. Nah, it's probably a little pointless. What I might do is just come into here and come into here, and we can just run it in a different terminal. And maybe this can be a chance that I can yeah, I'll just stop my ramblings there. So, what do we do here? So we can have we'll have an enumeration, and this enumeration we're going to be calling something like VT state. I think no, you just want that because it's the type of the single thing that comes in. Is that. And then I wonder if I mean, like, I could do something like this. I wonder how to speed that up. No, I'll just be a pleb and type it. Type the thing that was already there by hand. So we'll have that, and I'll do intermediate, and I'll uppercase more afterwards. I'll do that OSC string. Then we've got CSI M3, and then we have 4 things, and then we can have RAM as one, and ignore is one, and intermediate is another. And then we would have we have like like SOS, PM, APC string. He might have mentioned the reason why there's 3 things all in one thing. And now DCS also has 4 things, so we'll go here and ignore, and no, I kind of want to go that, and RAM, and oh, can I not do that? Intro, and we did have one more that passed through. And I might add another VT num dates, even though I think there's like so I kind of want to what we can do is fancy stuff. We can no, we need to like do that and then that, but and then it's that one, yeah. Cool. And how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now we could do something like static BT num, and I have gone 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. Use as designed, and we can have that sort of static assert there. And so we had to include assert.h, and that's okay. We can do something like that. Cool. That's all that. That took a bit of time, but it's all good. So now what we need to do is we need to have some way to process a thing. And what I might do is, because it will be inevitably required, is we're going to have a struct, and it's going to be a VT. I don't know what to call it. A screen, a state. But it can have nothing in it to start with. And we're going to have like maybe I'll have a like, I don't normally do it, but this library might become a library, I guess, because I said it. I mean, it's vt.c, but I might change it to vt.h. And because of that, we'll need some like for declarations and whatnot. And so what I want to do is, it doesn't need to return anything. But I just want to take in like BT state. I mean, oh, that could be interesting. It could almost return a new state. That's like the. Nah, I think I'll do this. Except here, I just realized I already called that. So I think I might just call it a VT. We're just going to have a VT. And I think one of the things that the VT is going to have is going to have a VT state. Yes. Remembering how to code and talk at the same time. It's a tricky endeavor. I encourage people to try. Even if it goes nowhere, it sometimes feels like you rubber duck something. But I'm going a little slow here, getting up to speed, I guess. So what I'm going to have is basically every public function is going to start with a VT object and makes it kind of like object orientated stuff. But I don't know. You need to have like some kind of state. And I've called this as state, but perhaps I should call it what? Yeah, so he calls it a state. So I think I'll call it a state as well. And what this is going to take in is it's going to take in UINT 8T, like that's what it can have up to FF. And so for that, it's STV int, isn't it? Yeah. So in here we can call it input. Right, so that can be our first function. So we can do something like that. I hate myself when I like do the, let's just scroll up the whole thing. There's ways to navigate a little quicker. And so how do we do this? And like, do we... I guess this is like an endless thing, but there could be cases where it could fail in ways we don't expect. And I wonder what we should do in those cases. Because perhaps we might want to allocate memory. We'll get to that. Perhaps we don't need to allocate memory ever. There's like some things that I mentioned, like there was a collect in the escape immediate, and there's parameters that you need to collect. He does mention some limits and what they are. I need to turn that boy off. We can move. Suspended. You're suspended. Just means I've been working a bit too long. So, like, I don't know. He has things like no limit to the number of characters, but a maximum of 16 parameters. So like you can just kind of drop it off after that. And then like, I don't know, the manual also says like anything more than that gets like clamped to that, but then another part of the manual says it can go up to that. So I don't know. We can think on that when we kind of get to each of those events. But what I kind of want to do here is kind of show the structure of how this might look. So when we process something, we want to deal with these anywhere things. So I kind of want to do a switch on input. You'll be seeing switch a bit. I warn you. If you don't like switches, like it's gonna happen. So if you have, and perhaps we should do the same as how he's got it there. If we have that easy, we now want to basically go. I want to do a little guard. If not VT turn, basically if we don't have a thing to play around with, we should leave. And I wonder if I want to do something like that, and then I want to return. And this doesn't exist, but does that? Oh no, of course it wouldn't. But that would. I kind of want to go here and maybe undo what I did, but then you kind of keep that, and then here I want to just prefix everything. And like perhaps the library could have a thing saying like, nah, don't worry about that. And then we just have lots of if deaths everywhere. But I think for now, just to be hygienic, we'll do that. Right. So what else do we have in terms of things? We have 1.8. So if we have 1.8, we want to execute things. So how do I want to deal with that? I kind of want to have another thing. So we're going to have a enumeration, another enumeration. I know, but I want to do this and call it actions. And perhaps we can have a similar kind of deal here, and do that. And here I want to basically just do a count out of all the like unique actions. So you have nothing. That is an action that should be taken into account. So nothing, execute, print, collect, ignore, clear, ram, ram, OC put, OC start, OC end, put, hook, ignore, unhook. So that I got 13 there. And what I might do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's why you go do that. Actually, I wonder how. Oh, I missed. There's like escape dispatching that, so that would have been those two. So these two that I missed, and I also included no action, which is the. But yeah, so I missed two, so that would have been 15 on my count, and then this was 14, so 15 was correct, but I missed two. But we'll go with take me back to where I was. What? I don't know why this. We'll do 15 there, and we'll start it off with, and perhaps we should prefix it with st action. I don't know. I wonder if you can get something like this. this, and I have to remember how to do it, but basically I want a buff new. Yeah, so I want a new window. Uh, put everything there. This didn't really do what I wanted, but we can do stuff like that. Slow. And then here, I think we can like buff do on a line that is just blank. We can just do that. Uh, wait, what? Oh no. Oh no, it's buff do G. Do that. So, because it's like gonna do something there. I don't know. But we could search for that and then do something like to the next one, delete it, and then Q, and then just something like that. And then how many do we have? We have 14. If we do something like so I guess ignore is the same as nor not processed, no observable difference. So this thing here, the no action, can be the same as ignore. Cool. So in that case, what I'll do is take that and then dump that down there, and then yeah, can we just do that? Yeah. Cool. And then so for all of these lines, I want to. We can do something cool here as well. We can go into norm, which um, puts you into normal mode for each of these lines. And so in here, we can go into insert mode. We can put in a tab, which would bump us over, but like using BIM's logic, I guess. And then I want to do a VT and then an underscore, and then I want to put escape in the stream, and then do A for a pin at the end, so the capital A, and then do comma. And if I do that for all of that, then it does all of that. And what I can do is now, it didn't actually do everything I wanted. So instead of going to the end here, I want to, like perhaps, that. I wonder if it would change it. I want to like go into visual mode, go to the end, and then squiggle. And then probably an escape. and then do that, and then boom, that did that. And like, I could have done it, could have. And you know what? Because we've got that ignore, this can be 14 because we didn't have the no action. Right, so now we have an action. I kind of want to do here and action, and so this is going to take the action, like the thing, and then we'll also do VT action, um, action, and then the input also, and then here I just want to briefly do that, and then do that, and then also do that back there. And that way, this thing can also have a kind of switch. So not VT. I'm not using this keyboard to the full advantage at the moment. My brain hasn't switched on this morning, I guess. But here we can switch on the action. And here, I've just put them all there. What I kind of want to do is yeah, I might do it. So what we can have is a static assert of yeah, this is what I want. So I kind of want to have another assert here of the same value. I know. But this is going to be a different message, not all actions implemented yet. And then in here, it's kind of just a way that we know we've done them all. But this is more of a useful thing when we're like incrementing up, I guess. And in this case, we've already kind of done this, and I'm going to default to them being unimplemented. And I might actually do something like that, and perhaps we can give it a message, do something like that. And here we can if std error and so I kind of want to do a particular format. And we limited and here we can pass in the format that has one, and as things I kind of want to go back to here and make this and perhaps here I want to do the same here. So here we can do one and like, do I even want to do? Oh. No, I think file line is fine. And then here we're going to have hash VAR, except without that one, I think. No, with that one. And I think to be healthy, I need to do here and then import. We're going to just import in these cases. I potentially could just ignore, but I think, yeah, I kind of want to do that. So here we need what do we need for that? STD for that pulse. And I think the board needs STD lib, which so far we've not needed. Set we've been using it, and it's kind of funny because like STDIO is part of STD lib, but it's not. Cool. And I'll take away that bad boy there because the whole point of the do while is that you can kind of just chuck that anywhere. So now we have a bunch of actions. So what I want to do is get all of the actions, and in action we have I don't want to do that. Do that and do that and do that and then do that and then find that and then change that. Cool. Now I also want to do on all of these lines long go pinned and then actually I want to find the first V and then yank the colon, and then I want to go to the end. No, I just want to pin to the end, and then we want to do input, and then that, and then I want to escape to go back to normal mode again. See, this is like real meta, but it's very powerful. And so now we can paste what we yanked back here into the stream wherever we are, and then we can append again and do something like that, and boom. Except what I want to do, you may have noticed, it wasn't in quotes, so it would be nice to kind of chuck in some quotes, and then it will kind of say exactly which case we are. And then we can have here, this is like a bad case. So I kind of want to do this. I kind of want to, now that anyone watching has seen how this is done, I kind of want to just make it all one line. Because now we can have something like this and Abu. And then find that, then do that. And unreachable is in the cases where it like should never be. So this is unreachable, and it may be reached. It may be reached if action, which in C-land is just an int type. So you can have negative numbers, you can have numbers more than number of actions. It doesn't have to be one of the values in the enumeration. It's one of the downsides of C, but you just need to know it, and it can allow quite some power. in certain cases, in most cases, it's kind of annoying having to think about certain things. But in this thing, I'm defining the actions quite slow, well, but yeah, cool. That hit there. It's going reasonably slow. So here I want to say unexpected action, and we can call it just that. Cool. So in these cases, we can come to implement them later, but what I might do is perhaps I don't really want it to be public per se, and this can just be above it, and it can have a little underscore just so we know that it should be doing something else. And all of this is so I can do something like VT action down here, and we can pass in the same VT. And the action we're going to do is, if I look up one name, execute. So we can go VT execute, and we can pass in the same input that we had. And then we also need to, this is one of the anywhere things, put us into ground. So BT state equals BT ground. And then we can break. We could potentially just return out of, no, actually, yeah, this I do want to return. So in these cases, I want to return out of all of the cases, because it's like, it's processed it. Now, perhaps I want to, no, this is good. This is good. This is good. But yeah, so this we also have. That was also going to be 1A. And it's also going to be like 8.0. And what I might do is do that and do that, and we just want to go to like, oh, can I go like E more? No, I can't go E more. So that cool. I'll just do that again and a couple more. Cool. And these I just those I want to do that on. So that's all these spaces. So I might do that and that and chase. I kind of want to do this. And here, the action is going to be if input equals 0x9, C, it's going to be BT ignore, otherwise it's going to be input. And either way, it's going to end up in ground. So that's going to be all of those cases. This case is into there. We also have that state up in there. So here we just have 0x9, 8, 9E, E, and F, and we can put them all on the same line. And this is also just setting the state, and that state name was something funny. It was that one there. Cool. Where else do we have it anywhere? We have one there, and DCS entry, and CSI entry. Gosh, can you get interesting? Lots and lots everywhere. So what I might do is do this one just because it's one, that one just because it's one, and that one just because it's one, I guess. I don't know. If we're going around, we could potentially like order them by what it's starting with. And you can just go there, and that was GCS entry. And next one, and that was 9D, 9D, and find D, and go to OCS string. And then find the D and replace it with B, and then find the O, and then this is CFI entry. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That looks good. Right, so I might actually put these a bit different. Yeah, maybe just because they also do actions coming in, I'll put them first. But yeah, hopefully that kind of makes sense. So we do the initial. So I might actually say anywhere state transitions. So that is all of those cases, and we do return in every case, and perfect. So now we should be, whichever state we're in is what we do. So we will now switch on whatever state we are in. That it came up with that is that option. So here we have a bunch of states. So what I might do is in here we can grab all of those and just dump them here. Go to there, and yeah, so here I want to I'll do that norm trick again. So we'll find the V. When we find the V, we can kind of actually I might do this and then find the comma and then replace that with exit, then I, then A, then that. You have to like picture in your head what is happening, but this will happen for every single line. And like, if you do it often enough, you get reasonably skilled and proficient, and you'll be able to do it quite quickly when you're not talking about it. But when you're talking about it, you have to kind of think about it because it might go wrong. But at this stage, what I've done is basically I start everyone on column 0, and so I'm here. I find the first capital V. All of these lines start with V, which is a thing that I did, maybe intentionally. And then I want to yank everything to the Y, and then I find the Y, which will put the cursor there. And then I was going to do capital C and change it into a colon, and then I'm like in the insert mode. But that would have wiped out what I put in my yank buffer. I could have used a register to yank it into, but I opted into using X instead, which I hope doesn't do that. If it does, I can come back and yank it into a register instead. Anyhow, so then I append a colon space because everything needs that. Actually, no, at the start, we need to put in a case space and then escape to get back to that. And I think I want to go yank to comma. Oh, so what I can also do is go this, and so I did Q colon, and you can do Q a lot of things. Q forward slash to go into a similar little window. This is like all the commands I've written ever. But yeah, so what I can do here is maybe do some editing a bit better. So here we yanking into, maybe we'll just yank into A, find that, and then we can change those two for that. Do that, and we'll do that, and we'll do an escape key. And to get that escape key, I go Control V, then just push escape, and it does an escape key. And then here I just go P, and then I go A again, and then what am I wanting to do here? So here, yes, so I wanted to do something like input. I kind of want to do what's just a few lines up, but I'm also putting in the case at the start. But yeah, so when I do this, and I can go there, and then I can just go boom, and then it does that, and it got that. That is because so if we do that, is because I didn't paste the thing that I did. So it found the comma, and then it changed that, and then it did that. But now if I do this, it does that. And why does it? It's because, yeah. So if we undo that, and see, I can undo en masse, and then just kind of tweak what I'm doing. But what happened here is, why is there A there? Oh, yes, that's the register that I am. So, yeah, I want that. So once you come out of I, you kind of pull back in the cursor, but now this kind of does that. And all that is kind of just a fancy way of saying that. And I probably want a default or unexpected state. And I just realized I didn't actually pass in the state, and I'm interested. I'm always interested. So this, yeah, so it did complain, but it complained in a kind of weird place because that's not where it's defined. It's a macro thing, but here I was wondering whether it would complain here because I added it to the other place, but I didn't here where I copied it from. So here we don't actually use input at the moment, so maybe we'll do that attribute and unused. That's good muscle memory. Look at that, good muscle memory. And so all that does some things. But what we may as well do is kind of process this. And what we could do is even No, I think this is kind of small enough. You could almost like pull that out into another function to kind of do the thing, but here what we can do is what are we doing in escape? Did we lose ground off that original copy? We did, and what we can do is we can just select this line and find that norm, and it's just doing it on the last selected area, which is this line, and I've done it. And so boom, done that. And what I kind of want to do is find this static search for the states, and also do that there. And here we uh, what did I say in the other static search? This one, not all actions are implemented. So the idea of this is if I add another action at some point, which in that case I would probably take away this static assert. Potentially it could be then a warning or something. I don't know. Yeah, I think you can do warnings. So you can do like if num actions equals 14 hash warn. It's been a while since I've done it, but I've potentially seen it, so that's kind of what I'm thinking. But yeah, the idea is if I add more actions, then it will complain in this point here, which is where I need to implement it. And so what I kind of want to do here is do that and like yank that and then paste that there. States, and it's kind of funny because not all states are implemented at the moment, but once I've done this smaller one, if I decide to add more states to it, then it would require addition here. Right, so this makes more sense. We've got ground up first. So what I kind of want to do is somehow get this bigger, you know what I mean? That kind of helps. And what I'm here, yeah, that kind of works. Didn't pop up this. It's kind of interesting. All right. Anyhow, enough rambling. What happens on ground? So here we want to potentially even want to outsource this to like its own thing, but potentially no. I don't mind having just a kind of double switch thing here, but this isn't that. It's a switch on input and do something like that. And so if the input is something like that, and then at the end of all that will break. Hope this is making sense. But yeah, so here we have this, and do we still have this? So can we go like, I guess 10 of that. It did do the right thing, cool. And so now I want to do like 16 maybe. That's not the one I wanted to do. That's all good. So do something like that, and yeah, that was a bit overshot. And then here, kind of want those to be there. And I think there's a config option I can do to do that. And here, I've actually noted I've made a little boo-boo. I wonder if I can do that. Or give it a go. So I noticed I put a comma instead of a colon. But what I could do is maybe do replace the find that and then replace it with a colon, and then join a line and then see what it does. And what did it do? Kind of did things, but what if I do that? Just kind of want to do things like that. And that last one didn't fix that. So in this case here, we want to do that execute thing. So we did have action this thing here. And here we can just kind of call that, and here we know the action is going to be execute, and we can just pass in the same input. And so that's kind of just a nice way to kind of keep this inner switch quite small, and that's why I'm not too fussed about having more, I guess. Yeah, got a little, yeah. So it kind of makes things easy if we want to do something like so we have 0x2o, and so here I want to do quite a lot more, like 100 more maybe. Except here I kind of want to change the macro that I was doing to kind of come up there, and then find any colon, go back one, and uppercase it, which in this case does nothing. Don't know why I went there. I like just tap the button. That's kind of annoying because I was in a macro. Right, so we'll get in the macro. We'll append it. We can just to there actually go up one and then get out that. And then I guess actually the macro I want is at this point here, create a new line, yank and paste, and then find the actually go back to there and do that, and then do that, and then go up to join that, and then join that, and you should end up in the right place. And I think now if I do however many I want, yeah, so now I kind of want to do 100 and then see where I end up. And the macros aren't like the quickest way to do it, but all I wanted to do is get to 7F, which, yeah, that's kind of interesting. Some of these did not change. Oh, this is quite frustrating. Why did it do that? What we can do is in here we can replace a thing, which is A to Z, and it's followed by a colon. And I kind of want to do this just on this line, doesn't matter. And I like to select anything. Do we have to do that? Yeah, we have to do that. And it's just A to Z. That's kind of annoying. how do we do uppercase on this? It's all the B's, the D's, and the F's, I think. So B, yeah. Did I not do that? Yeah. And then that didn't really do what I wanted. The B, D's, and the F's. Oh, is that right? The worries of that. And then here we can just have the VT action. It's a long line, like it's 128 characters long. No, it's 1,001 characters long. It was like 100. Yeah, line 128 and characters 1,000 characters long. I think it's all right. We could split it up into like chunks of like 16, I guess, and then you just have 2, 3, 4, 5, 6, 7. That one's done. This is what I want. And if it is this case, we also want to do print. But in general, this is kind of the boilerplate on what we want to do. And so that's now implemented. And what I kind of want to do is we can copy that and kind of paste it here and then just change. So we're in escape now. As an entry and an exit, I wonder how I handle that. I guess we could, instead of doing this VT state equals that, we can have a VT state equals transition. Yeah, so I think I might want to do that. So in here we will also have like a transition, and we're going to take a VT state, and it's going to be, well, it's actually we're just going to take a 2, and we don't really care about the input at all in a transition, do we? I think not, because here we will do the action, which I guess, yeah, we need to check for arrows going out and do them kind of separate. So on the transition, again, this one, so in here we probably want to check certain things, and here I want to check the num state, so I want to take this one and put it back here. Here we're going to check the exit. Is that what they call it? This one has an exit. Exit events, and then here we can do that. And so if we have an exit event, we would have, I think I just want to go through and do all of these. What has an exit? OSC string. So if we have a case BTO SC string, then we have an action. So this needs to be oi, oi, oi. Um, it's because I don't. Um, that wants to be there, and I also wanted it to be gone from up there because I need to call action. So T action, and that was it took a VT. What else did it take? It took action next. So here we have OCN, OSC end, and also the input, which if we have something like that, perhaps the input we want to say whether there is input or there is not input. Not sure about that. Anyhow, what are the exit events are there? Exit unhook. Look, now it's which state it is. So it's in DCF pass through, and then we want to do an action of. We could even do something that, and this is going to be BT unhook, and also put the break up there, and yeah, we can do that, and that just makes it a little cleaner. So here, like, we don't actually implement all 14, and that's all good because we only care about these stats in this particular situation, I guess. I think the compiler will complain about us, but we can move around that with perhaps a thing. So at this point here, we make the transition, and then now we have entry event, and here I know it's only a few lines down, but I actually want didn't quite do what I wanted. I still want that static insert in this case because who knows? This method might grow quite large and you might not see. Um, um, I don't want to call that handled and maybe search for that and that and that and no, that took me back to exactly what I wanted, wasn't it? Now, yeah, cool. Right, so entry events. Now we need to see what has an entry. We have an entry in escape. So here we can go to escape, and here we can go to BT entry. No, it's clear. And we also have one in DCS entry. Uh, entry, and here we can also go to clear, and these are both clear, so I can actually tidy some things up. So what I might do is do something like that and do that, and just because it's multiple, I'll do that. Now I saw another one case VT OSC that, and at this point here we want the end action. Getting me. The time when you just take a space into buffer, and here we can go OSD end is the event that we will run, and those will just call that other function up there. And so what are the wait, no, these are entry, and OSC start, OSC string. Yeah, I need to start thinking. I haven't been thinking up until now, you see. But no, that's we want OSC start, OSC start from string. Because these are states, and it's kind of I kind of want these to be labeled as a state, and I think I can do that. I might say that what I'm going to do is going to start a macro. I'm going to mark a going to end the macro, start a macro. I'm going to mark A as the current point, and that means that like if we go away, we can go back to A like that. So what I'm going to do is get this. Going to open up a. That didn't do. All right, so that's interesting to know. All right, I'll mark A. You can't. I think you can get it in here though. So what I want to do is now I want to over the whole file. Golly, I want to check the thing. No, that's all good. Over the whole file, I want to check for. I want to replace the thing that is I haven't listed anything right. So I want to probably go to there and yank to the end and also mark A, and then here we can replace all of whatever we just pasted in. Cool. And then we can this is kind of annoying. We can do this a bit better. I just want to get it perfect, so at this point here, I'm gonna find that and yank to the end, and then mark A, I guess, and then I'm gonna paste the whole file with any reference to VT underscore, the thing that we just put in. I don't even know if this will work, but we'll find out. And then I want to replace that with VT state. And then the thing that I had. And I want to do that globally on the line. And then I just want to do it. Cool. And then I want to go back to line A and then down one. And then close the macro and see if the macro will work. Cool, look at that. Didn't quite work there. It kind of did. Yeah, and then we can just do that. And here, I kind of want to do I kind of need to do the same thing, but I think it's stored somewhere. Like I think, yeah, like that is uh, my hopeless attempts at the macro. So what we can do is actually replace this with action, and then do something like that. So I just yanked that into Q again. And then if I do Q, yeah, see, look at that. Cool. So, and now what I can do is I can bring the line my cursor is to the top with ZT. And now, because I have rel num on, I can see num actions is 13 away. So I can go 13 and run Q again, and it'll just do a bunch of stuff. And that's now kind of refactored all those things. So now, wherever I was before, I should have saved a mine before. These are now clearly states, clearly actions, and that just kind of makes that a bit easier. Anyhow, I was doing entries, so CSI entry I have not done. And that's just the next entry, I guess. So here we can go case VT, and here it's also useful because we can underscore state, and then we can see the CSI entry. And then here we can, on the O, find the next one usually, and here we wanted clear again. And so because of that, this can just go up that one. Now, sometimes you got to type things out and then realize you're being a little dumb. Cool. So now if I do this, that O can be DCS pass through, and this would be makes sense. Now we need to find cases where we go VT state equals something, because we have it in a bunch of places. So what I want to do in these cases here, you can do it with regular expressions, I think. So if we look for VT state equals, and then start a parameter, then VT underscore dot star, or maybe even square bracket a to V, and also underscore and then square bracket. And if you search for that, but that character starred, that should find all the cases like that. And it's also captured that VT thing there. And now, instead of doing that, we can just go VT transition, and we go VT, and we put in the back reference of 1. And we don't need to worry about the colon at the end, and we shouldn't really need to do this in more than one place. So if we do that, it's just changed it everywhere that we were kind of doing a thing. So that makes that a lot easier, because now we can handle the exit and entry event. These are the anywhere transitions, so we can have that. And perhaps like this could get broken out, but perhaps it doesn't really matter. What I kind of want to do is do that, and perhaps also scroll down here. This process, the input, it needs to be kind of clamped in that kind of interesting way. So if input is greater than 0x, and we know it's a UN 8, so we can just say greater than equal to 0x a o. This is identical to 2o, so we can just do something like that, and gosh, what is it? It's like a minus 2. On the border, it's like 8. That kind of makes sense. Yeah. I think you could almost, 2's complement, you can't. I was thinking you could almost just take away that flag, which you can because these are all positive numbers. I wonder if the compiler would do that for me. But basically, I want to do input or it's there, or equals no, I want like n equals 0x 7f. That's kind of what I want, which would be quicker than a subtract, which like potentially I will just do that. Like some people do stuff like that. So 7f. Like, is that kind of what I want? Yeah, because it's definitely above that, and we want it to be up in that range. So codes in GR A to yeah, map to GL to 0 to 7. Yeah. Same as removing Dutch as there. Because it's just removing that top bit, and that's like I know that I think I'll just do that. And if people reading code are like, what's that doing? You can reason about it to kind of see that, and that comment is kind of saying that. Cool. So what do we do next? So we just did escape, I believe. We're doing it in a funny order, but we're doing it in such a way that we can kind of collect everything, because we haven't actually covered all the cases here. And like, first off, does this compile? This doesn't. Yeah, so complains about that. Can I see ignore W's which enumeration just for one or several? Tell me, people, is it possible? Yeah, you can do that. Yeah, you can do that. Can you not just throw a thing? All right. So, like, it's a useful error. but like I don't really want to have to include everything in it. But if we do, yeah, I think I will. So we'll get these, and the compiler will complain about different thing after this. So we do that and then see first. See second, I guess. So here, if we do this, if we find the um, string, that one, and the pass through, that one, and then these, I wonder if like we kind of want that, but also kind of uh, we kind of want this, but we kind of want just the find the comma, then replace with a colon, and then do J. Thank you. Yeah, it doesn't do that, but just do that. It's something like that. And then this will be a little different, but yeah, why is that like off by one as well? That was just a copy paste, I guess. Do something like that. And like this will complain about other things. So here we it really cares about the num states. Sure. All right. I think BT state num states and BT num states. Like that. All right, and now it should take me back to there and then or there. Right, so here we don't want that. That's cool. Duplicate that is cool. Duplicate. Stack getting more interesting. We've got a few commas, don't we? Not on the next one though. We change that for a colon. Yeah. That we do on this one. Or that's interesting that this one, but because I feel like oh yeah, both of these that had an entry were also in the output. Yeah, cool. That's fine. Right. And these switches you don't need to put all the values. Golly, that would be quite insane. I mean, I kind of am. Like I'm putting in a lot of values, like I'm playing, but that's kind of what it is. So these are the ones that that does that, that does that. Before I was doing this, I wanted to It's interesting that I've got this. Where did this 20 to 7F come from? Because 20 to 2F is there. I think this is meant to be in the ground one, which, yeah, it is. This is still just a copy paste. Golly, need to resolve that. Right, so in escape, we have the entry that's already sorted. This goes to 17. We probably just didn't finish doing this. This has also got 19. And do we still have the. We don't have any macros. We can kind of make one. We don't really need one. It's, we'll grab that, do that. Cool. So that's going to be that. What was that line? Yeah. Do that and do that. Cool. So that's going to be these actions. This is going to be 0x 7F. Cool. And this is going to be ignore. And we've already dealt with the entry. So now we kind of want to deal with all the various other ones, the transitions. So 20. So maybe I want this to. This is a fancy one. I'm going to yank to F, and then take me back to this. And so if I just paste that, I probably could have yanked found F. Do that and then put in the F. That just does all of those. And so this is going to be VT transition from VT. Well, it's gonna do the action, I guess, of collection. So it's going to do that, and then it's going to transition to VT escape state, escape intermediate. Perfect. And then we can break out of that. So that's one of our transitions. And yeah, I guess like, I don't know, we just want to go and do things like that. So like if we go here and I'm just going to see if this works. I don't know what it does. That was kind of weird. Is that like a bin bug right there? Like, am I allowed to? Funny. Cool. Anyway, so if we find the F, yes, find the F, and then do it again. And so if we get that, that's going to be that chunk. We can see that 51 and 57. So if we find the 51 case and yank find the 7, that's going to get those values. And so if we just paste that there, 51, 57, if we do that, we have 5, 9, and then we should have 5, 8. Right, so those are all the transitions to a different thing. So instead of collect, we're gonna escape dispatch, and then here I think it's just going back to ground state ground. Cool. Um, so that's all of those. What about this bad boy over here? So that's just a couple. Case 0x5 x 5 e and 5 yeah. And this is going to be a transition with no action. That's cool. We can just not pass an action, I guess, and we can have ignore that. We just don't need an action here, and so that's going to sauce that one. EVPV. Right, so what is next up on these? We just have a couple more single bytes. So I wonder if I should order some things here. Because yeah, makes it maybe a bit nicer to kind of see. So we have a 5.0 case. We also have a 5D case, and we also have a 5B case. And I think there'll be 1, 2, 3, 4, 5, 6 transitions. So if we look at this, we have 1, 2, 3, 4, 5, 6 transitions. Yeah, because that's just an action. Maybe I do want the actions just by themselves to be up there, but I don't know. I think having the order is beneficial. So these are all things on nothing, on nothing, and on nothing. So 5 goes to and if that's the case, I wonder if I want to do something like that. Just these small ones, like having just like a nice line can be kind of nice. But the giant behemoths, you do kind of want to see what's happening. And even having 3 is a little much. But what we can do is get 3, get this, and then find that. And so 5B, where are we going? 5B is CSI entry. So that's CSI entry. And what I'm going to do is just get that one. 5D is OSC string. That's that here. OSC string. And this 5.0 is DCS entry. DCS entry. And here we can just make those a little nicer like that. I think that looks quite nice and tiny. Like it is large, and we've only done one, but it's what it is. All right. So, what does escape intermediate do? That's what I was going to do. While I was compiling, I was like, I wonder. but I think surely it doesn't have ranges. Yeah, because it just treats it as an integer, and it'll be like, what are you doing? You're subtracting a thing, and you don't really want to. C is 1,000 line right there, but we can kind of take chunks from it, which is kind of nice. There are like functions you can call, or you can even just do like little bit switches to see, oh yeah, that's in that chunk, oh that's in that chunk, something like that. And that can get away with that. I wonder if the compiler will kind of do that for me. But anyhow, what does escape intermediate kind of look like? It's got a few events, but it's going to have the same kind of structure as this. So what I might do is just take that whole giant thing, but here we can I'll just blank out things just so we don't accidentally do things. And cool, so that's all that. So what action do we want on like the lowest number? That's just 0 to 17. So do we have a 0x17 somewhere? We do, and that's just this whole line, isn't this? 1, 2, 3, 4, 5, 6, 7, 8, 9. We miss, no, yeah, A, B, C, D, E, F, and 10, 11, 12, 13, 14, 15, 16, 17. Perfect, cool. So if we take that back there, do that, and we just want to execute. So 20 to 20F, so if we look for that, and I think that line, yeah, that line is a good one to do. And that is going to be a collect, no transition. Then we have the 3 to 7E. I think like this might be a bit better. So like the 3O is here. So if we do that and just get like the rest, we don't really need to visual that at all. But it is what it is. Down a bit more, isn't it? Yeah. So if we do that and we bring that up there, so 3 to 7 at, and then that's going to be escape dispatch, and we're going to go to ground. Perfect. And then 7F was going to be ignore, and I believe that already come had a case there. Perfect. And you see, with the groundwork that I did kind of earlier, this is now getting into cool, what's happening at this one, what's happening at this one, what's happening at this one, and you can kind of copy paste and just yeah. So where do we get up to now? We have OSC string. That's kind of an easy one. It's got one transition out. The input is already covered. The entry and exit events are already covered. We just have already done that. But what we can do is kind of take that behemoth and this behemoth, 0 to 17, we already have. That we want to add to this 19, and the C to F. 1C, is this just what I want? The 0 to 17, then C to F. And so what we can do is we'll do that. And 17 is in the same place. That is just what I want. Here, this is going to be ignore in this case. So if we search for that, ignore, we want to ignore the input when we're doing this. And then the 20 to 7F, which I believe is probably just that. Here we're going to have an action of OSC put, OSC put, and we're not going to have a transition. We're going to have a transition on 9C though, and that transition all over the place. So we're going to have it no action on this actually. So we're just going to have a transition from VT to ground, wasn't it? VT. What am I thinking? Mind blank. Start state ground back there, and so we just have that. So if we're just in transition, we may as well do that. And that's that. Easy. And you can see, like, once you kind of get the framework of a state machine, it's reasonably quick to kind of make right CSI entry. So here we've got a few errors out and some entries already sorted. 17, 19, 1C, that's just exactly what we want, except here we want that to be execute again. This one here, so do we want, we need to F, we can probably break out into a separate chunk. We also wanted 30 to 39, so we can probably break that out, and we wanted like if one onto there, and then do that, and like I don't know where this 3A is going to end up at the moment. 3A is just by itself. The 22F that's already done, and the 47E is in that point there. So 7F we have a ignore. So I guess I'll just search back for an ignore event and kind of chuck that there, and 7F 7F do something like that. Cool. So what do we happen in this? That is a action, and so the action is going to be collect. We're going to do that. Then we're going to do the transition into BT state CSI intermediate, and there is no more args to that. So this that was not in the right place, that place. Right, so this 31, so the 3 to there, and the 3B, we've got that. So this is also a transition, but to RAM, you can just copy paste that. So instead of that, it's a RAM, and the collect can be a RAM. That's what we're doing in those cases. The 3C to 3F, we can deal with the 3A first, actually. The 3A was just a normal transition, a single transition to CSI ignore. Ignore, and then can break on the end like so, and so this 3F was back up here, still to that one, and instead of param it was collect, but it was going to the same place. That's all good. Right, this 40 chunk, that was just to CSI dispatch. So we have an action. We also have a position. And that wasn't quite what I wanted. Something like that. But we can do something like that, and then do that, and then that. But I mean, two of those. This action, what are we doing? Action is going to be CSI. This tank perfect. The 7F, that was correct. Ignore. Perfect. And that one was a little bigger, but you can kind of see that it's. The first one took a while, but now I've kind of chewed through them, and it's like a lot quicker. And some of it depends on what you copy first. So CSI param will kind of get that, and it will likely be related to CSI entry. That's kind of what I find. So the up to 17, the 19, the C to F, we want to execute. Perfect. The 20, where do we have 20? 20 to 20 to F, that goes to F, and that's collect, and that goes to intermediate. See, like that's just a perfect copy paste. And then here the 3A to so here we've got them in here. So 3A to 3.9, and then 3B is just a param, and we don't have a transition because we just stay in the same state. 3A, and then also we want to chuck on 3C to 3F, so we can kind of bring that there and do something like that. And so now we should have like this 40 chunk. So from here, the 40 to 7E, which is just that, we do the same CSI and pull to ground. Perfect. And we should have a 7F. Perfect. Easy. So that one's done. And if we do that, so and ignore that looks about right. Of what I can see. But yeah, the 20 to 3F. So I guess I'll search for 3.0 and then do that, and then yank find the F. No, yank find the F like that, and then we go back here. Oh, but we wanted. Yeah, cool. And then here we can just paste that there. Yank that there. So that's 20 to 3F, and it's also got a case 0x7F on the end, and this is just going to be so this is it can plan in the other place surely, but yeah, this is actually an action on the which so now we've got all of those covered, all of those covered, all of those covered. So 40 and whatnot, this just doesn't have any mappings for, so we don't need that, and the 7F is already covered. So this just has the two things there. And so just because I saw that, it did complain. Oh, this is a duplicate case value. This is Interesting. So 7F we have up in here. What are we in? We're in escape immediate. Small detour. 7F should not be in that big one. So we go here, just do that. And yeah, so here, see, implicit, it's interesting. If I didn't have other warnings, it might not complain. Right, so what are we in at the moment? This is, what are we in? We're in CSI Ignore. Oh, that's just jumping away from there. Easy. So, oh, we also have this 4E. Did I get rid of it already? Right, 4E to 7E, and now we're doing a transition to ground. So transition, and the CSI we're going to ground, and there's no second thing there. So here, the CSI ignore. We just want that to be an action ignore. Action ignore. Is that correct for the 20 to 3F and the 7F on the end? Perfect. And cool, that's all that. Right, so back to what we were at. CSI intermediate, I will likely not grab the ignore case, but this one here. Or not there. That other side of the keyboard. Cool. And so here we can do that, do that. Because intermediate will likely have the same things. 17 and that says execute. The 20 to 20F. Excellent. That's just collect. Same as that. We don't need to move anywhere because we're already there. 33F. Right, so this can be a bit wider. So we can find the F on that one, and maybe, we can just do that. It's the same as that one, perfect. And that is going to be a transition into the ignore. So that covers that case. And we should have everything up to 7E, dispatch, and then ignore for that one. Perfect. We're getting close, and this is pretty much done, apart from the actions. But we'll get to the actions. There's only a few of them, but I hope this shows that, jumping in and finding a state machine like this, like it's a smallish picture, and just going through and doing everything, you feel valued, maybe. I don't know. But anyway, this one, what do we have? It just ignores pretty much everything. So what we can do is, not that one. Also want to go from there and go there. We can probably just do this. So we want 19, and then we also want 20 to and this is going to be ignore as well, the action. And we're also taking 20 to 70 27F here. So we need another case on the end, 7F. So this is just everything almost, I say, almost. So from 0 all the way up to 7F pretty much, but the 7, 10, 19 is a gap there, perfect, 1C to 1F, and then it should be from there reasonably stable, perfect, goes to 7F, and we should also have a 9C which transitions to so case 0x 9C, and that can just do a little thing like that. And this can go away. Easy, DCS entry. Right, so DCS entry. This has also got a bunch of stuff coming out of it. What I might do is find the CSI entry and grab that, and then didn't really get to where I wanted. Should have kept a mark or something. Entry's already done. Event, we just need to do this to 1F and just ignore that. So this should be ignore. And is that correct on CSI entry? We're executing that one, but we're ignoring it in this. All right, cool. There'll be reasons for the madness. And we also want that on 7F. So we could probably just do 7F there. And then the rest are transitions of some of the script. So 20 to 20F, we collect and we go to DCS intermediate. DCS intermediate, perfect. 3A, we're ignoring, so that's going to be the same thing there. And is this like one that, yeah, so the 30 to 39, then B, this is going to be RAM, and this is going to go to the DCS, perfect. And then the 40 to 7E, which is likely this one, this is going to go to the DCS version of dispatch. No, it's not actually going to do that. It's just going to transition to DCS pass through, and this is going to be DCS there. DCS there, perfect. And then that goes to the pass through, and 7F. Already covered, we just chucked it up in the ignore there, easy. And so transition. So that's already done, but this and that can be done. Cool. So the ignore, I might find the CSI ignore, that one, and this, yeah, and we can just get that. I did not, well, we can search for DCS ignore, that's where we were up to. You remember to set marks. This will likely be the same, so we're going to have ignore. We're also going to ignore the X0x7F, and we're going to ignore that. Ignore. Perfect. Look at the ignore. And then the 20 to 7F. So yeah, if we look at the right one, this is just 20 all the way to 70. Take me back there and do that. Do that. The 40 goes there. Then 0x. 0x7. Yeah. All of that. And so that is also up there. And they're just a giant big behemoth of a thing. But we have some gaps there and there. And then all the way up to 70. And that is just ignoring except for case 0x9c, and that is going to have that open. That seems right. Right, so the param, I might search for CSI param again. CSI param. So if we search for that, I don't want to go back twice and then set a mark to there, and then we can search for this one. That's all good. Search for that. Do that, and then back to A, and then do that, and then do that, that, and then figure out what parameters meant to have going on with it. We have ignore for those ones. Look about right. Right, where's 20 go? It goes to collect and it goes to intermediate. So this will be ECS intermediate. And program also has 30 to 39 and 3B. It goes to program, and then 3A, 3C goes to DS, GCS. And then the 40 to 7E goes to DCS pass through, and it doesn't have an action. DCS pass through and no action. And 7F is also an ignore. So I'll just chuck it on the end of that. Something like that. We're almost there, so maybe I'll do that same trick, search for the CSI intermediate, and grab all of that one's chunk and then go back just a couple, and I was a bit better at searching then. Right, so in DCS intermediate, we have some ignores, excellent. Then 20 to 20F, we have collect. And then 30 to 3F, we go to DCS ignore. DCS. And then 40 to 7E, we go to DCS. No, we just go to DCS pass through. DCS pass through. It's a little different, and then there's also that one there. So we can just go 0x7F, and this should be ignore as well. That's good. And then that can go, and then this is just the last one. And then you got to deal with all the events and whatnot. But this video has been quite a while, so what I might do is I'll get it to the point where all the like states are done, and then we can maybe call it. Nothing really to see, but the next episode we'll go through and put in all the actions, and then we'll kind of see what happens. Just because I've got a few rumbles, if you know what I mean. Got a few got a few rumbles. Anyhow, this right. So what do we want to get? We'll just grab this one as our like little mock one, and we can kind of do that. Do 19 C to F. That's what we've got there, plus some. So we don't want this, but we do want 20 to 7E. So that one. That one and that one. Is that right? 20 to 70 after this pretty standard one. Cool, so 20 to 20F, and then that goes there, and 7E, perfect. And so this action is going to be put, and then we also have a case for just 7F. 7F that way around, and that is just going to be an action for ignore, and then that can go up as well. And so none more for that, and then that's that, and then the default is all good. So it's pretty crazy, but this is the state machine part of that. So it does all the transitions and whatnot. So, I mean, we can do a little sanity check. So we have anywhere states. That is good. Do we have the ground state for those last few that we kind of added in? Oh, that's not what I wanted to do. Thought I was in the right thing. Right, so yeah, we do not have that. So if we have a case 0x9C, that is going to be a VT transition, VT and we're going to just go back to ground and break that as well. And so this transition may be required in some other places as well. So maybe we'll take a little copy of it. Like intermediate, do we have it there? No, but we do have it in ignore. What about param? No. So just ignore, and we do have it there. Perfect. What about in soz or DCS entry? No. Soz 9C. Perfect. Where else do we need things? We also need an OCS. Or where is our OCS? Do we have an OCS? OCS string. OSC string. Right, so if we have a look at this one, golly, we were just there. Surely it will highlight somewhere. We have the 9C. Do we have it in CSI ignore? Sketch intermediate with C, CSI, CSI param, ignore. So we don't have, no, we probably do 4 to transition ground. And this should probably have a breakout of sanity. Right, so if we have a look through this, I'll just do a like little sanity check for little things that we can do to kind of tidy it up so it's not like just a giant gross thing. So this is kind of broke out, but I'm of the mind of just doing that, and that's just kind of what it was. This because that's how I've done it with the others later on, and that kind of frees up quite a bit of space there. Cool. So this, in theory, is doing a thing, and what we could do is almost take input and then print out what our state is at every point in time. I think I might do that, just so something can be kind of seen from this. And perhaps I'll also get like the strings of what the things are. Yeah, I think I will do that because they'll need doing. So we can have a static char star. It's also like const. And these are VT state R equals, and this is going to be an array of things. So we do it at that end, and then we can just kind of do that. And I can do this sort of thing. Is similar to kind of before. We're going to find the V. We're going to yank to like the end there, and that's going to kind of give us something. And we might actually yank that into a thing. Cool. And so now what we can do is we can probably go back to the start where we are. And I have a tool to kind of wrap things with things, if that kind of makes sense. So what this is going to do, I'm sitting here and I'm going to wrap until the end of the word, which is here, with square brackets and with no space because it's the closing end bracket. That's the terminology of that. And then here we can find the comma again, then like replace that with equals, and then we can put a little quote there, and then we can go to skate. We can print the thing that we have. We can then and then do that, and then do that. Yeah, I think that's that. And that didn't quite do what I want because instead of that, we want to get it from a register. And then that is basically defining us an array like that. And so what we can do is also do a similar one for the actions, which I might do just before I kind of commit to things. So we're going to have a static const char star VT action strings, and we can call this a thing, and here we can we want to go to there. Golly, go to there, and then it was just that norm, wasn't it? I didn't do quite what I wanted. So what we need to do is, so I guess here we do a norm. We'll go to the start of the thing. We insert that thing, then we escape. Go back into that and escape, and then we go to the end, then we append, and then we close the thing, and we do that. And that's kind of what I wanted before, but we can do it as we pass through. Cool, and then if I do it again, that just works there, repeatability. Cool. So what I want to do here is maybe just do that, and we can probably make a static or like VT state str of the state, and then in here we can have if state, and we can like wrap that a little extra. If state is greater than or equal to 0 and state is less than VT num states, then do, and I might just do this and add in another. Then we can do the VT state strings, and I'll call that there, and we can pass in our state as the argument. Otherwise, I'll just do defined. I think we can do like unreachable, unexpected state, and we can just pass in whatever it is that we got, and we can just do something like that. And I think you can do that in the middle of that because I chucked it in thing. And we call that strings. And then this is, of course, a define type thing, and we can do the same for actions, and we can just replace state with action and do it everywhere, and then also do state with action and do it everywhere, and then it'll just kind of magically make everything look right. So if we kind of make a VT object, so we're going to have a VT, and we can just call it VT, and we can initialize it into have nothing in it, which is good. And the default state will be ground, which is what we want. And that kind of works out nice. So what we can do is we could like pass stuff into it. So at the point we have here, we can go, so take a pointer to my VT object and process the string or the character, isn't it? And like, what happens if you process a escape character, for example, which I think you need to actually do like that. So at this point here, we can printf start in state, and we can pass it as string, and we can get that VT state string, and we can pass in. Perhaps we just want to do that. Nah, I do want to pass in the state string like that, and then we can just do that. And then after that process step, we can kind of say that. And what does this have? It does not like that because we don't have a pointer at this point. We just have a value. That's perfect. Yeah, so I wasn't sure if you could do this. Vector state out of bounds. And maybe we can just taking a snapshot for you, do something like that. And I just realized I want to replace all of those with stacked, because otherwise it will replace the literal state there, which I think it won't replace the stacked there. It requires a full word. And probably the same thing here. So take this and I think put this here and then replace, we already have this, and then we can just do this one with stat with act. And that won't do that, but we can action out of bounds there. Cool. That's all right. We can in action we can maybe do it like F and F std error got action set s and put set s state percent s action s, yeah, something like that. And then we can go VT state, and then we can give this action, and then we can pass in the input there, and it'll probably complain now that we're using the input, which is my hope, I guess. Transition from state to state, yes, and this probably requires VT state string listing of 2, and it also requires that there and 2 there. Oh, no. Yeah, and do something like that. And it's actually a transition from the state. And then here we have state action. Do something like that. Yeah, and I thought that might go there. Do I still have it? Nah, I don't. VT state string of that thing. And this is going to be DT action string of whatever that action is. And then that will be that. And what's this? Oh yeah, so input we can maybe just do O2 X, and maybe with a capital X, like so. Cool. So now this kind of works. And like what would be cool is if I hooked it up to a standard input, and when I ran it, it would kind of show the states in real time. But what I think is, I think I've still got a window. If I run this, we start in ground, we transition from state ground to state escape, and action clear. That was the entry thing, and then we have an unimplemented on 109. I wasn't expecting an unimplemented. That is because we haven't actually implemented any of the actions. But you can see here, like it's doing some things, and like you could do some other things. Who knows? But yeah, I think I will leave it at that for now. I might actually commit all this up. So if we add that, and we can commit. So this is implement the state machine sans actions for VT500 using William's VT500 state machine available at and it's just at that point there. Cool. And then I won't give a full name for the guy. Paul Flo Williams. Paul Flo Williams, and then maybe do that, and then do something like that. Sounds good. I think that's cool. If people are interested in this, I will keep on working on it, because I've got some plans for this, because there's a few things that I kind of over and over re-implement the CSI stuff. So it'll be kind of cool to have this as a neat little library that I can reuse. Anyway, thanks for watching, and hope you enjoy, and check out other videos and whatnot. I'll do range of stuff. See ya.